Hi, and welcome. This is our final look at Cross 13, a small but surprisingly complex brood. We've encountered some unexpected variations, making it a real challenge to pin down their exact genotypes and phenotypes. While the core Snow White traits are there, these deviations are throwing us for a loop. Let's see if we can make sense of it all. If you're new to the channel, I'm Ivan, and my mission is to establish a Snow White Guppy line, all stemming from our original male, Gandalf. We're in the intercross phase, focusing on two goals: a stable Snow White line and understanding the iridescent forehead trait. Now, Cross 13 was a unique detour, using a gray-based Snow White male instead of our usual blonde. It is a cross between a male from Cross 7 and two females from Cross 8. The history and ancestry of Cross 7 will be very relevant for this video. Just a quick recap. In Part 1, we met the Cross 13 parents, highlighting the gray-based male. Since Snow Whites are typically blonde, I was really curious about the outcome. We also discussed selecting the Cross 8 females, which, given their subtle Snow White traits, were chosen with the guidance from Cross 5. Sadly, the male passed away early, but luckily, the females had already bred and continued to produce fry. In Part 2, we saw the fry developing color, but they weren't mature enough for a full phenotypic breakdown. The real head-scratcher was the red pigmentation, totally unexpected since the parents showed no red. We also dug into the magenta gene, exploring the possibility of some fry lacking it entirely, which could explain the red. Plus, I shared my theory that a single copy of magenta might not cause fin reduction. Part 2 was more about theories than hard data. Now, with the fry fully grown, we can finally analyze the phenotypes and see how our predictions hold up. But honestly, even with this data, the genetics here is still a bit of a mystery. There are just too many variables, and without isolating and testing these potential new genes, we could only speculate. Alright, let's dive into the data. Cross 13 produced 24 fry. A smaller brood than I'd hoped. Larger sample sizes make statistical analysis much easier. This might be due to the C7a male's early passing, limiting the female's fry drops. However, I'm not entirely sure. The duration females can produce fry without a male is something I'd love to experiment with once I have a more stable line. Of the 24, we had 14 males and 10 females. We'll start by analyzing the males' phenotypes, then move to the females. You'll notice some guppies with physical abnormalities. These won't be bred, but they're valuable for genetic insights. Also, one Snow White male recently passed, but I'm including him in the count. I'll point this out whenever needed. First, we sorted the 14 males by base body color, resulting in a perfect 50-50 split, 7 gray-based and 7 blonde-based. Next, we looked for red coloration. The absence of red usually suggests the presence of European Blau. None of the gray-based males showed any red. However, 2 of the blonde-based males displayed red, while the other 5 did not. So, overall, only a small fraction of the males showed any red pigmentation. Now, let's talk Stoerzbach expression. I've realized I've been too narrow in my definition, focusing only on back iridescence. Stoerzbach primarily affects the body, and it appears all the males are expressing it. That's a positive sign for stabilizing our Snow White line. However, I'm particularly interested in the degree of iridescence on their backs. I suspect this is governed by a separate gene or set of genes, as many of you have suggested in the comments. Let's examine the iridescence distribution on their topsides, specifically from the head to the dorsal fin. Among the gray-based males, only 2 showed slightly elevated back iridescence compared to their siblings. The 2 red-blonde males had no topside iridescence. The blonde males with European Blau split, 3 with iridescence, 2 without. With about a third of the males showing back iridescence, it suggests a possible recessive gene. Given that the C7a male had this trait, I suspect one or both of the C8a females contributed to this varied inheritance. Beyond the phenotypes we've covered, there's more to observe in these males. Notably, several display distinct patterns, and the unexpected red coloration, given the parents' lack of it, is quite puzzling. We'll circle back to these points later. For now, let's shift our focus to the females and perform the same phenotypic breakdown. Then, calculate the overall distribution. The 10 females split into 6 gray-based and 4 blonde-based. Interestingly, while none of the gray-based males showed red, one of the gray-based females did. This left 5 gray-based females expressing European Blau. None of the blonde-based females showed red, indicating they all expressed European Blau. Similar to the males, all females seem to express Stoerzbach. Unfortunately, females don't typically display the same topside iridescence as males, due to their less vibrant coloration. So, let's look at the overall genetic distribution. Ideally, for a stable snow white line, we'd see 100% inheritance of our desired traits. Since that's not the case here, it's crucial to identify which genes are nearing fixation and which need more work. Starting with base body color, we saw a 54-56% split between gray and blonde. This nearly even distribution was expected, given that the C7a male carried the recessive blonde allele. Now, for the red coloration versus European Blau expression, we saw a 12-88% split. The low number of red guppies is definitely intriguing. Assuming European Blau is indeed responsible for suppressing red, the presence of any red guppies suggests at least one of the C8a females must be heterozygous. This is puzzling because neither female showed obvious red, and I initially believed they both carried the recessive European Blau trait. Upon closer inspection, one female does have a subtle yellow tint in her tail, and under specific lighting, faint wisps of red. Could this be our answer? Let's do some quick math. If both females had equal fry counts, we'd expect 25% red offspring if only one of the females was heterozygous. To match our 12%, the European Blau expressing female would have to produce 4 times the fry compared to the heterozygous female. With only 24 total fry, that would mean the heterozygous female produced a maximum of 5. Possible, but it feels unlikely. This highlights the challenges of small sample sizes. Larger broods would provide more reliable data. In part 2, I suggested these red guppies might lack magenta, partly because I'm unsure what a magentaless guppy would look like in my line. Alan Bias's reference states magenta boosts red pigments and iridophores, and converts yellow to red. Based on that, saying the red guppies lack magenta seems unlikely, but the math actually fits. Let me explain. Magenta is dominant, so for this to work, the C7a male would have to be heterozygous. This is plausible. Cross 7 should have a mix of homozygous and heterozygous magenta guppies. Since magenta is mostly dominant, I couldn't distinguish between them based on color alone. So, C7a could indeed be heterozygous. If both C8a females were also heterozygous, 25% of the brood would lack magenta, double what we see in Cross 13. However, if only one female is heterozygous, that drops down to 12.5%, almost exactly matching Cross 13 without adjusting for brood sizes. Remember, brood sizes likely varied, which would only slightly alter these percentages. Now, while the math aligns, it doesn't definitively prove magenta is the cause. We're still working with a small sample size, and other genes could be at play. There's another point to consider regarding the magenta theory. Alan Bias also notes that magenta causes fin reduction. If our red guppies lack magenta, they should have longer fins. Some males do appear to have slightly longer fins, and while it's not immediately obvious in the red males, they do seem to have slightly larger tail fins compared to pure snow whites. So there's a possibility. Fins take time to develop, but I can't keep this brood indefinitely. I need to move on to my next breeding projects. I might keep one male to observe further, but I'd hope their fin growth would be more conclusive by now. Alright, let's continue with Cross 13's phenotype distributions. Next up is Stoerzbach. It appears all of Cross 13 expresses Stoerzbach, which is excellent news. It suggests we're making progress in solidifying these genes step by step. Now, the final step with Cross 13 is selecting our next breeders. While I typically prefer males with high back iridescence, I've decided to choose females from this brood. As I mentioned in the Cross 14 finale, I'm pursuing an iridescent forehead trait, which I believe is X-chromosome linked. One Cross 13 male shows slightly more forehead iridescence. So by using a female, we increase the chances of passing this trait on, especially since I plan to cross them with a Cross 11 male, who also displayed iridescent forehead signs. I've selected 3 blonde females for this purpose. To avoid the brood size distribution issues we faced here, I'll only collect fry from one female, keeping the others as backups. One more distinctive feature of Cross 13 is the prevalence of patterned males. Roughly 50% of the males lack the solid coloring seen in their siblings. I have a hunch about their origin, though the exact genetics is unclear. While I don't intend to breed for this pattern, tracing its ancestry could shed light on why it appeared in this cross. Let's trace back to the roots. Cross 13 is a blend of 2 lineages, originating from my original females numbers 1 and 2. Female 1's brood showed 2 distinct phenotypes, males with wild-type patterns and males with red tails. I kept one of these pattern males, and here he is today. He's nearly 2 years old with a slight back curvature. I didn't breed him, but I was curious about his development. The females also mirrored these phenotypes. I back-crossed both, leading to crosses 6 and 7. Cross 6, using a red-tailed female from cross 1, still produced some pattern males, showing these genes persisted despite my choice of female. Conversely, in cross 7, I used the female that correlated to the pattern males from cross 1. This resulted in about 50% of the males having less vibrant, washed-out coloration compared to their half-brothers from other crosses. They also lacked the distinct patterns of their uncles, instead showing a faded appearance. It is from this cross that I selected the C7A male, choosing the most vibrant, solid-colored snow white male I could find. I'm highlighting both crosses 6 and 7 because cross 6 still yielded patterned males even without using the patterned female. I believe a similar phenomenon occurred in cross 13. Despite using the C7A male, who showed no patterns, 50% of his sons displayed patterns or a washed-out look. It's kind of cool having these documentations to look back on to see how these traits resurface. In essence, Cross 13's complexity stems from a blend of genetic factors, making it challenging to fully decipher. Despite clues pointing to various possibilities, the exact genetic interactions remain elusive, and likely will. Pinpointing them would require extensive breeding experiments beyond my current scope. However, we've gained some valuable insights. First, we've learned that unpredictability is inherent in breeding. Unexpected traits can emerge, which is often how new guppy strains are born through mutations. While I'm not claiming any new mutations here, it's a reminder that there's always more to discover. Second, moving forward, Unless I'm certain females come from true breeding lines, I'll focus on using only one female per breeding. This will simplify data analysis. I'll still introduce multiple females for redundancy, but I'll collect fry only from the healthiest female to drop fry first. This approach will streamline our data and improve consistency. And that concludes our deep dive into Cross 13. While it didn't deliver the pure Snow White outcome I initially envisioned, it was a valuable learning experience. If you're keen on seeing more selective breeding analysis like this, please subscribe and follow our journey. In the next video, I will finally officially introduce my next crossbreeding project using my Snow White Guppies and some beautiful half-black red roses. Now, for some quick updates on our other crosses. Cross 15, involving Thorn and Cross 11 females, is facing challenges. The first fry drop is showing abnormal swimming, and the second drop appears to have failed. Cross 16 between my C9A male and C11B female is progressing well, with 6 healthy fry growing nicely. Cross 17 between Thorn with his daughters from Cross 14 is underway, but my primary female has developed late red coloration, so I'll shift focus to the backup female. If you're interested in the origins of Cross 13 and the rationale behind the parent selection, check out this video. Thanks for watching, and I'll see you in the next video.